Do you guys remember the ways that you were taught to solve a system of linear equations? There were 3 ways that you were taught. Do you remember any of those? Sides equal to each other. Okay, I think you're talking about getting into doing elimination, where you want to get the numbers in front to be the same or opposites. Sure, I'll teach you that again. Samantha? Yeah, I would say, Samantha, elimination is my go-to, unless it like screams at me, like with one of them, if one of them was like y equals everything or x equals everything, then I would probably use substitution, where you take this and substitute it into the other equation. But there's one way that no one's mentioned yet. So we have elimination, which I think we'll do the most. Substitution. There's another way that you would actually have to use your Chromebook for. Starts with a G. Graphing, right? You can always graph these, right? These are, I said these. These are all lines. So as long as you graph the lines and find where they intersect, that intersection point is the solution. All right, so you can always do that if you'd like. All right, so let's do this first one. Now, when you look at this first one, right, I try to use this one as like, again, this is like my like easy pitch to you to try to crush it. What do you notice about the numbers in front of x? They're opposites. So right now, my goal when I do this, especially if I can choose whatever method, I usually choose elimination, is I try to get the numbers in front of either the x variable or the y variable, I don't care, to be the same or to be the opposite. Do you see how these are the opposite? If they are the opposite, then I can actually add these equations together, and what will happen to my x variable? Okay, well, let's use the word for the name of the method. It will be eliminated, right? It will make 0 because negative 2x plus 2x is 0, right? And that whole idea is if I eliminate one of them, I can solve for the one that is not eliminated, okay? So then I just need to add, what's negative 4y plus 6y? 2y. And what's negative 6 plus 16? 10. So what is y equal to? 5. Now, whenever you get one of these answers, whether it's x equals your number or y equals your number, don't forget that a solution here, right? A solution here should be an ordered pair. So an x and a y. So I need to plug this back in to either the first equation or the second equation to find the x value. Is there one that you would like to use? The first, you do the bottom one. We'll do the top one. All right, so negative 2x minus 4. But then what am I replacing y with? 5. So that's negative 2x minus 20 equals negative 6. How do I move the minus 20 over? Add it. So I have negative 2x equals, I think I heard Natalia say it, 14. So x equals negative 7. Did you get the same thing? Nice. Now, I'm not sure how they want you to type it into IXL, but I would always write it as an ordered pair. Any questions on the first one? Everybody good with elimination? Okay, excellent. Let's do number 2. Okay, number 2. Do you see either the numbers in front of the x or the y? Are they the same or the opposite? Are they? I don't see any of them are the same or the opposite, right? It would need to be like 9 and negative 9, or 3 and negative 3, or 10 and negative 10, or 1 and negative 1. So this is your choice. Again, I always choose elimination if I have a choice, most likely. The only way you could convince me to do substitution is if you wanted to rewrite this as y equals negative 3x plus 20. You guys see that there? How I moved the 3x over? You could then take this negative 3x plus 20 and substitute it into that other y. That's totally fine too. You could do that. But I would think most students would do elimination here. So which one do you want to eliminate? The x or the y? The x? Okay. So what I think most students would do is they would multiply the second one by what number? 3. Now, some teachers will tell you to multiply by a negative 3. Why would some teachers tell you to multiply by a -3? So you get opposites, and then you can do addition. I'm going to let you choose, right? If it's me, my brain, I'm going to leave it as a positive because I can subtract. I have confidence in my subtraction abilities. But if you're worried about subtraction, just throw a negative here, right? And make all of these the opposite as well. And then you can use addition. It doesn't matter. Okay, so here we go. Ready? So copy down the 9x plus 10y equals -10. I'm not changing that equation. But what's going to be my new second equation? You're good. Plus 3y equals, careful, equals 60. No, it's a really good mistake to make, Natalia, because that's a very common one. Students will forget that it needs to multiply by all of the terms. So that's why this is 60. All right. So now what operation do I need to do? I need to do subtraction. If I do addition, I will not eliminate any of these variables. So yeah, go ahead, Natalia.
So if I chose the -3, I would add
So you would have -9x,
yeah.
-3y,
Yeah.
-60, and you would be using addition. You're going to get the same answer.
Okay.
Just the work will look a little different. So 9x minus 9x is 0. What's 10y minus 3y? 7y. And then this can be tricky. This is why, if you need the calculator, if you would like to use the negatives. What's -10 minus 60? -70. Okay.
You got like 1,000.
Yeah, nah. Never mind.
Well, you just cleared it.
Yeah, I know, because it just realized what I messed up.
Okay, all right. It's okay. We all make mistakes, Hector.
I did too bad.
We all make
You
mistakes.
know when like somebody's arguing about like, no, it's 10, like, no,
Yeah.
it's 11, and I have like 83 in my calculation.
Fair enough. Well, maybe it's 83. I don't know.
Maybe they were both wrong.
Exactly. It could be. What's -70 divided by 7? -10. Awesome. We found the y. It's your choice now to go back to one of the originals. All right. Which original do you want to use? The first one or the second one? The second one or the second one first? 3x plus y equals 20. Let's plug in our y of -10. Let's move that over with addition. So I have 3x equals, what's 20 plus 10? 30. So x equals +10. So my answer is 10, -10. I will say in teaching this a couple years ago when I used to teach Algebra 2, a common mistake I'll see from students is at the end when they're writing the answer, sometimes they'll switch the x and the y. So make sure when you write your answer, it's always x, y. All right? Even though we solved and found the y one first, make sure it's x, y. All right? All right, let's do one more, and then I'll give you guys the rest of class to try. So the last one. All right? Yes, I'm sorry. I'll go back to Tali.
No, I was actually asking about 3.
Oh, number 3. Yeah, go ahead.
For that one, would you put it 10 next to the
I would multiply the top one, all 3 terms, by 10, but there are some other options. Some students might actually multiply the top by just 2, because if you multiply the top by 2, you get a +4y, and that's a -4y, so it's add to 0. So there's many options. Some students even might actually move this -x over to make it a +x, move this 11 over to make it a -11, and then substitute that into the x and the other one. There's so many options here. Okay? So do you want to multiply everything by 10 in the first one? Okay. What? Go ahead, Luke. Okay, let me back up. So you're saying we can add or subtract right now to eliminate?
No, I was just asking.
So the reason we multiply in some of these is because we're trying to get either the same number in front of the variable or opposites. Because if we get the same number or opposites, then we can either subtract or add to eliminate one of the variables. So we were saying that you can multiply all of these in the top by 10, and that would give you opposites. Or you can multiply all 3 in the top by 2, and that would give you opposites for the y's. Your choice. All right, so let's do the 10. So that's going to be negative 10x plus 2y equals 110. Copy down the original second one. What happened? Yeah, so that's the common mistake is you got to multiply all 3 of them. We're going to choose addition because the signs are the opposite. So my x is eliminated. Did I multiply this by 10? I did not. No one stopped me. There we go. I made a mistake. No one got it. That's okay.
What do you mean?
I didn't multiply my 2y by 10.
Oh, no, it's because the way you said it sounded funny.
Oh,
My X is eliminated.
okay. Well, that's not what I meant. My variable x is eliminated. What's 20 minus 4? 16? And what is this? Is this 96? So is 16 times 6 96?
Yes.
I think that's right. Okay. I'm going to plug this back into the original first one. So the opposite of x plus 2 times 6 equals 11. I'm going to move this 12 over with subtraction, and then we're going to have a quick conversation like Hector and I had. Okay, so this is something that it kind of sometimes can take students a little bit of time to understand. We're right now at this point saying the opposite of x is equal to -1. Do I want the opposite of x? No, I want x, right? So if the opposite of x is -1, what is x equal to? +1, right? So you always just take this sign away. So what if it had said the opposite of x was equal to +1? Then x is equal to -1. Okay? So this solution is 1, 6. All right.